Alright, in this video I'm going to show you how to do another question on moments. So we've got a diagram with a stone slab AB of mass 1 ton, resting on two supports C and D. The stone is uniform and has length 3 meters. The supports are distances 1.2 meters and 0.5 meters from the ends. How many children, each of mass 50 kilograms, would need to stand at A in order to tip the stone over? So let's add our forces on here. So we need the weight of the stone, which is going to act right in the middle because it's a uniform slab, and that weight will be 1000 G because 1 ton is 1000 kilograms. G because it's a weight, the acceleration due to gravity there, and this will be, well, one meter from here, from the middle of that support. Okay, and then so 0.3 meters from there, but I don't really have space to write that in. Okay, how many children of mass 50 kilograms would need to stand at A to tip the stone over? So if the children are here, then they will be exerting a force here, and we'll say we don't know how many children, so we'll say that their combined weight will be 50 G X. Okay, X is our unknown number of children. Okay, and if it's about to tip, if they're weighing it down over here, it's going to be tipping about C, so there'll be a reaction there. But if it's actually about to tip, there won't be a reaction at D, or the reaction at D would be 0 because it would just be not resting properly on D anymore. So we want to find the limit, so the point at which it's just about to tip, so it's still in equilibrium, but there's no reaction at D. So let's take moments about C. So we don't need to worry about the reaction force. And what clockwise moments do we have? Well, we've got this 1000 G, the weight of the stone, and we just said from C, the middle of that support, that would be 0.3 meters. And then we're only going to have, in the other direction, anti-clockwise, we've got our 50 Gx times 1.2. And it's still, we're saying it's still in equilibrium, so that's going to equal 0. So now all we want to do is solve this for x. So as often happens, we can cancel out our g there to avoid any rounding errors. And we end up with 300 equals 60 x. Okay, and then we need to do, x is going to be 300 divided by 60, which is 5. So 5 children can stand at A. Before it tips. So if even one of those children were holding a rock of even 1 gram, theoretically it would tip.